Hey guys, welcome back to this course. In this topic, we'll actually take a look at this particular concept right here. You can see this geometry preview in the Rhino window. We'll actually be creating something like this, and we can create this kind of a geometry using Grasshopper using this particular component, which is known as Metaball custom. You can actually find Metaball custom right here under the mesh tab. You can find it under triangulation. Over here, if I click, and you can see you have Metaball custom over here. You can use Metaball custom to create 3D and 2D geometries like this. So I'll just go ahead and disable all of these things so that you guys can actually understand how this is created. I'll just enable this and I'll turn this on just to explore how the Metaball custom T works. So you can see that everything is changeable here. I can go ahead and change the width and the height of this form that I have. I can change the height of this entire thing just like this. I can also go ahead and play around with the number of count that I have, the number of points that I have, like this. So I'll just change it back to 10, and let's say I can also go ahead and play around with the domain start and the domain end, which will actually increase and decrease the the attachments of all these blobs that you can see. Also do that, and you can also go ahead and play around with the seed, which will create different kinds of shapes and different kinds of forms. And you can also change the number of contours that you have in this sense. So I'll just change it back to 1. You can also play around with the count of this thing, but that's totally subjective. And after you are satisfied with all of these things, you can turn it on to get a 3D geometry. So let's go ahead and make this script from scratch, and let's understand how Metaball 2D and Metaball 3D actually works in Grasshopper. So I'll just go over here to File and open up a new document so that we can start creating the script from scratch. So the first thing that we'll require is a rectangle. We'll create a rectangle and then we'll create a 3D box out of it. So let's double click and type rectangle. So you have the rectangle component over here which says create a rectangle on a plane. You can bring this in and you will have something like this on your Rhino window. Now you can double click and type XY plane to input the plane over here. Bring in the XY plane component. This is the plane that you have. So we can actually hide this plane so that we can see the rectangle clearly. So you can use a central click and use disable preview to hide the plane. Now let's go ahead and bring in a number slider to attach to X and Y. So you can double click and bring in the number slider, or you can just use the shortcut where you can just double click and type any number that you want. Say I just type 40, and I have a number slider from 0 to 100, and I can actually double click and change it to 40. And I can plug this in both X and Y so that I have a square which has a size of 40 by 40. Now let's go ahead and give this thing some height. So we have the rectangle coming out of here. We have the geometry as you can see on the Rhino window. So you can double click and type box. And you can have, you have a lot of box options. The one that we need is box rectangle, which actually creates a box defined by a rectangle and a height. So you can bring this component in. This component you can actually find over here under surface, and it will be located under primitive. So let's attach rectangle to rectangle, and you see that by default a height is already created. A 3D box is created out of the 2D rectangle that we had. You can actually see that the height is by default it has a height of 0 to 10. It has a domain height of 0 to 10. Let's attach a number slider and control this. So you can just double click and type 80 and attach a height of 80 to this box, and you will have a box like this. You can parametrically control it like this. I'll just keep it back to 80. Now let's go ahead and attach a populate 3D component to this box so that we can actually populate this entire box with small points, and we can actually then plug it inside our Metaball custom component. So you can double click and type populate 3D, bring this component in. This component you can actually find under vector, under grid, and you see it asks for a region. So the region that we actually want to populate is this box. So you can plug this in And you see now your entire box is populated with points in all the three axes, which is X, Y and Z. You can also attach a number slider to control the count. So you can double click and type 10 and press enter. Attach this to count. And you can also double click and type any other random number to attach it to seed. So maybe I'll type something like 375 and attach this to seed. So now I can basically increase and decrease my count and play around with the location of these particular points. So once you're satisfied with this, now you can actually take these points and you can actually use it for your Metaball custom component. So let's see where the Metaball custom component lies first. You can go to this mesh tab and you can click on triangulation and you can find Metaball custom, three Metaball custom components. The simple one which creates a 2D Metaball, then you have 2D Metaball isosurface, and then you have 2D Metaball isosurface by custom charge values. This is the one that you need, the blue one. You can click and bring this in. Now it asks for points. So the points are the points out of these things. So you can just double click and type point, bring the point component in, attach it to population. Now you have all these points separated over here, so I can just turn this off using the disable preview. You can also turn this off using the disable preview. And now let's attach this to points. It also asks for all of these inputs. You have to input a charge. Now in order to input a charge, we actually need to input some random numbers. So let's double click and type random and input the random component that we have already seen before. It asks for the range, the number and the seed. First you need to understand what charge is. Charge is basically a point charge or a value which can be positive or negative, and it will actually give the geometry some depth or some shape. So if you input a charge of say 5, then the curve size or the curve shape will be manipulated by the amount of numbers that we actually input. So a curve with charge 1 will have a small radius, a curve with a charge 5 will have a bigger radius, and so forth. So you can actually manipulate this by inputting some random numbers. So I'll just input this over here for now. After inputting it, you see it actually gives you an error saying you must supply equal number of points and charges. So over here you can see that the count is 10, but the count over here is 1. So you need to supply equal number of counts, which is equal number of points and equal number of point charges. So if you have 10 points and if you have only one charge, then you cannot supply one charge to 10 of these points. You need to have 10 points and 10 charges. So the number of random numbers that you are inputting, or the number of charges or the charge points that you are inputting, has to also be 10. So this 10 will actually go in here. Now you see that the component starts working again, and you can actually see some output over here. You can see a small plane. Now we can actually input some plane geometry over here before we proceed. So let's input a plane geometry, but you need to understand that the plane that you will actually input has to go in 3D. It cannot go in 2D, because you see you have a small geometry over here that is forming. It's part of this iso curve. You can actually play around with all of these things, but you need to understand that this is in 3D. It's not in just 2D. So you need to have the planes. These planes has to be in the z-axis also. So we need to create an array of these particular planes. So you can just double click and type linear array. You have the linear array component which creates a linear array of geometry. You can bring that in, and we can just attach the XY plane in geometry, because we are trying to create an array of planes, an array of XY planes in the z-axis. So you can just double click and type XY, attach XY plane to geometry. That is the geometry I'm trying to array. But as you can see, you can attach, if you attach this, it arrays itself in the x-axis. We need to array it in the z-axis. So you can double click and type Z, bring in unit Z, attach it to direction. Now you see it arrays itself in the z-axis, but we need to give it some kind of a gradient. So let's just double click and type 1 and attach this. But you can also change the maximum value of this to maybe 50, but make sure you keep it at 1. So if you attach this, and now you can actually change the count. So let's change the count to something big like 110. Attach a number slider with 110 to count. Now you see you have a lot of planes in this particular manner. You can just control the count like this. Make sure it surpasses the box, otherwise all the Metaball objects will not be seen in the box. After you are done with this much, after this particular setup is done, now geometry can actually go inside plane. So these are the planes on which you will be actually creating your Metaballs. So I'll put geometry inside plane. Now you see you have small objects forming around your points. And after you're done with this much, now you can actually control these random values that you are inputting. We have not yet inputted the range and the seed, so that's why you have these small kinds of geometries forming over here which you cannot really see properly. So let's actually fix that. So fixing a range will actually fix that. So I'll just move these two number sliders over here.